Hello, my name is Jimmy Costello from the NX Product Marketing Team, and today I'm going to be going over how to utilize multi-body holes and threads in your workflows to improve product design efficiency. To begin, we are going to take an inner assembly from this coffee machine, take a deeper dive into how we can improve a tube casing between the water tank and its pump. We are going to look at how we can create holes on each end of the casing so that we can add fasteners, brackets, or screws to improve the structural integrity of our casing. The first thing that I'm going to begin with is just creating a simple hole at our first datum coordinate system. When I do this, you may notice that our hole only passes through the top plate and does not reach the bottom. Initially, this may appear to be an issue with our depth limit that we have set. To see if this is our issue, I'm going to change this option to value, and you can see now that the preview of the hole appears to extend past the second plate. To check if this works, we can select Show Result at the bottom of the Hole Commands window. You may notice when we do this, our hole is only found on the top plate still, despite our new depth limit. This is because we need to select all bodies the hole must pass through under the Boolean tab within the hole command. This option at first may be discouraging, but ultimately helps provide a much more customizable experience where holes do not produce unintended results. Now that our first hole has been completed, I want to take a look at a different approach we can utilize when creating screws which pass through multiple bodies. The Hole Series option within the hole command provides the ability to change the type of fit for each body that a hole passes through. This is particularly useful in cases where a fastener or screw is threaded at its tip. As you can see, there are different sections for each body, and once our position point is selected, we do not need to select the bodies our hole will pass through. Users can customize the type of screw used as well as the form of the screw at the entry point. You may also notice that in the end specification section, because the match dimension box is checked, we cannot alter some of the dimensions for our hole. Once I select OK, our new hole is populated in with the corresponding threads and fit for the screw we selected. The last thing I want to discuss regarding our hole creation is how we can speed up this process when we need more than just a few identical holes. To do this, we can utilize the Pattern Feature tool found on the home page. The Pattern Feature tool offers a variety of different patterns we can follow, but for this case, I'm just going to explore the use of the circular layout. Once we select the vector and rotation point, dots will populate in, showing previews for where our holes will be repeated. For this instance, a pitch angle of 90 degrees and a count of 3 occurrences works perfect. Once this is done, we now have 4 holes which pass through our top and bottom plates, where we can now place fasteners, brackets, and screws. To review what we have looked at, we began by exploring how to create a simple hole that passed through multiple bodies within a part. After that, we went in and looked at a more advanced approach in Hole Series where we could customize the hole on each body to reflect and match the style of fasteners or screws which we would use. Finally, we finished using the Pattern Feature tool to repeat our hole 2 more times in our part. I would like to thank you for your time and attention.